Hi, I'm Steve Bell, Lean Agile NGO founder. Welcome to the Quickstart problem-solving training and exercise for frontline individuals and teams. This is part 1, problem-solving fundamentals. This is a review version, the first release of this video. If you watch this, I would very much appreciate your comments. What did you like? What would you like to see improved? As with anything, this can always be improved, especially with feedback by those who are using it. Here's the email address to send your comments to. Thank you. And if this is your first experience with the free training and exercise videos, I invite you to watch the brief orientation and introduction modules for an understanding of the overall mission, approach, and fundamentals of this training series. You can find them at the link displayed here. I call this training series Quickstart for a reason. When the hands-on exercises are done, you'll have a working knowledge with common problem-solving approaches and the ability to apply various types of problems in your situation. I designed this training and these exercises especially to help NGO frontlines individuals and teams. In my volunteer activities over the past 20 years, I've seen firsthand the many challenges posed by the lack of access to basic resources and the creativity and resourcefulness of local communities working with NGO support to solve their own problems and develop capabilities to sustain and thrive. I hope these free training sessions on lean and agile practice can help you to be even more effective. You may be anywhere in the world, in the remotest area, but if you can get to YouTube, you can get to this training. Because problem-solving skill is at the heart of lean and agile practice, and there's a great deal of variety and sophistication in problem-solving in different situations, there's a lifetime of learning ahead of you. But to get you started quickly while providing you with a solid foundation for future learning and growth, I've broken this training into 5 parts. In part 1, we're going to look at the fundamentals of problem solving. We'll explore how problem solving works, understanding the basic approach and patterns so you can make it a habit. In part 2, we'll step back for a big picture view of organizational context and management system behavior related to your problem solving efforts. Although this Quick Start training is intended for frontline teams and individuals to help you quickly improve problem solving in your immediate area, it's important for you to understand these larger organizational issues. No matter what relationship you have to a larger organization, whether you're an employee, a partner, or a volunteer, it will help you to learn how to deal with them effectively when you need to. In part 3, I'm going to cover one of the greatest insights I've encountered during my learning journey, the 4 different types of problems, how to identify them, how to make sense of them, and how to approach the problem-solving process in the right way each time. In part 4 are the hands-on exercises. I'll use the foundational lean problem-solving tool called the A3 to guide us through the complete problem-solving life cycle. And I'll introduce a variety of problem-solving tools and methods along the way, focusing attention on the essential ones. I'll walk you through this exercise as if you're sitting in a workshop with me, pausing for you to complete one section before proceeding to the next. You can do this exercise at your own pace, stopping and restarting the video as your timing allows. In part 5, I'll put topics I feel may be important to some of you, but are optional. Along the way, I'll provide plenty of coaching tips and many links to free additional videos and other quality content sources so you can guide your own learning journey and practice forward. Well, I call this series of videos Quick Start. They're not quick. Some parts are quite in-depth because this is a deep topic that requires learning and practice. As the old saying goes, those things worth doing are worth doing right. There's likely more here than you or anyone will completely absorb or master the first time through, but that's okay. An important part of learning and growth is to be comfortable with a little discomfort. Stretch a little bit. I believe that whoever you are, wherever you are in the world, and whatever background and experience you have, you can handle this. So let's get started. Here's a list of the specific problem-solving tools and methods I'll address in Part 3. As I just mentioned, there's clearly more here than you can develop proficiency with in just one session. I'll share enough on each so that you can understand what it is, how it works, and what type of situation you might apply it to. And I'll go into depth on a few that you're likely to find most useful as you're getting started, leaving you a trail of breadcrumbs for more free, quality online content to pursue further learning when and as you wish. I want to begin this session with a quote from Dan Jones, one of the two fellows who coined the term lean in the 1996 book Lean Thinking, which launched the global lean movement. At a conference 12 years ago, I heard Dan describe lean in this way, and I have never forgotten it. My current hypothesis is this, and I choose my words very carefully. Lean is a journey. Lean is the practice, not theory, but derived from experience, of using the scientific method, PDCA, hypotheses and testing, in order to gain insights into how we can intervene in a dynamic system to make it improve. I find it fascinating that even in this statement, he's speaking like a scientist. Even though I consider him the greatest expert on lean thinking, he still frames his comments as his current hypothesis. He's always open to learning new things. Now read this once more and ask yourself, does it sound like he's talking to NGOs directly about intervening in dynamic systems to improve them? In an interview in March of this year, Dan and I went into considerable depth on the nature of lean and the various dimensions of problem solving, with a specific focus on NGOs and nonprofits looking forward. You'll find it on the interviews page of the website. In this interview, you'll hear Dan speak of the importance of establishing a common language for problem solving across an organization. He stresses that we must teach everyone a disciplined way to frame a problem, seek root causes, and try alternative countermeasures to find a solution. And he emphasizes that most important of all is not the solution to any particular problem, but attention to the problem-solving process itself. This is how an organization and everyone within it learns how to consistently solve problems, continuously improve, adapt to change, and guide themselves forward in a meaningful way, especially in times of uncertainty and constant change. So why is good problem-solving skill so important? Asking questions and solving problems is a key to growth and development, and it's also at the very heart of continuous improvement and innovation practice. There's a great deal of emphasis in education these days to help children learn good problem-solving skills so they can sift through the relentless information and complexity and make good decisions. As it turns out, most adults need to learn quite a lot about how to do this too. When we learn to confidently and courageously find, prioritize, and solve problems, we unlock the potential for ourselves, our families, our communities, our workplaces, and our planet. There are many different kinds of problems. Some are small, what I like to call 10-minute problems. Some are simple, while others are complicated. Some are guided by logic and physical laws, while others are influenced by strong agendas and emotions. Some problems you can solve by yourself. Others need a team, while others require the whole organization. Here's the key. All problems are solved using the same basic pattern, the scientific method. But there are many problem-solving approaches and tools based on this simple pattern, each suited to a particular need. There are a few key ones to start building your toolkit. That's what this Quickstart session is for. So where do we start? The first thing we must understand is that problem solving doesn't come naturally for most of us. We have nature and genetics to thank for that. Science has clearly shown that we have two modes for problem solving, fast and slow, crisis response and slow deliberative thinking. Instinctive crisis thinking leads to predictable errors in judgment, memory, and decision making. It happens when we're under stress. And who isn't under a lot of stress these days? But if we're going to address the problems our future generations face, we need to get better at this. So let's take a closer look. The reflexive brain is automatic and impulsive and crucial to our survival. Our limbic system, the ancient animal brain, quickly kicks into fight or flight mode. It's instinctive, which means it happens before conscious thought begins. If we have to stop and say, "There's a bus about to run me over. Let's consider my options," it's too late. In the very core of our ancient brain sits the amygdala, about the size and shape of an almond. It acts quickly and automatically to override our thinking brain. The problem is, in today's world, we're conditioned to stress, so our minds and bodies react to nearly everything as a crisis, pumping the stress hormones adrenaline and cortisol right into our bloodstream. And we tend to jump to conclusions and solutions far too fast, even when we don't need to. We're often influenced by strong emotions, opinions, biases, preconceived notions. We have to be very clever to intercept this automatic response. It has to be learned, practiced, made a habit. The slower, deep thinking brain is a recent addition that has developed in humans, and its advances in cognitive capability have made our modern world possible. But we don't always exercise these capabilities. In order to survive, early humans needed to conserve energy, and these higher brain functions take a lot of it. And there are many things we do repetitively that we don't have time to think about. So we often replace thinking with habits and muscle memory. For example, once you learn to ride a bicycle or drive a car, you don't have to relearn and think too much every time you get on or in. This habitual behavior and muscle memory is necessary in our daily life, and when we want to, we can intentionally build it with practice, which is something we'll explore in Part 3 and do for ourselves during the exercises in Part 4 as we internalize new problem-solving thinking and patterns. However, it becomes a problem when we run too often on mental autopilot. Often we need to stop and question our assumptions and habits. And during a busy day, that can be really hard to do. Even more important, once we spot a significant problem, we need a simple, habitual pattern to follow that guides us down the problem-solving path in a way that's appropriate to each situation. That's what this training is about, because we now live with constant VUCA: volatility, uncertainty, complexity, and ambiguity. We explored this in an earlier video training session. Good problem-solving skills have become both more important and more difficult, so we must learn and practice the patterns of problem solving, not just as individuals, but as teams and as organizations, because often good decisions made at the individual level can be overridden by the many common dysfunctions of an organization's prevailing mindset and culture. The way to effective problem solving in all situations is grounded in the same mindful and deliberate pattern known as PDCA, Plan, Do, Check, Act. This is the scientific method which led humanity out of the Dark Ages into the Renaissance and forward. We introduced PDCA in the Fundamentals of Value Stream Flow video training session. PDCA is a pattern that can help us slow down and think deeply about our unquestioned assumptions, biases, deeply ingrained habits, and instincts, not jumping to conclusions or solutions. We should look at the problem from many angles, forming hypotheses about what is wrong and what we should do about it. Well, it sounds simple. We've already discussed how this is not natural behavior, and it's especially difficult when we're under pressure, for most people. Albert Einstein was not most people. He once said that if he had an hour to solve an important problem, he would spend the first 55 minutes thinking about the problem and the last 5 minutes solving it. Einstein was a theoretical physicist, not an applied one. By his own admission, he wasn't as good at math as his peers. The insights he developed about the nature of physical reality emerged as story problems, incredibly complex in his head and on a blackboard. It would be decades before technologies evolved to test many of these theories in real life. The deep thinking brain is far more powerful than we think, and the PDCA pattern can help everyone tap into it. During our first exercise, which begins in a short while, we'll learn the most common lean problem-solving method called the A3 approach, which is an elaboration of the PDCA pattern. People always ask, why is it called an A3? Because it's named after a large paper size, an A3. But it can be done on any size of paper, a whiteboard, or on the back of a napkin. What's really important is not the name, but the pattern. You start by defining the current condition. What is happening now? By examining the evidence and the data. Then you describe what you want it to be, called the target condition. Then you figure out the differences, often called the gaps. Then you analyze the problem, what's keeping you from reaching your target. When you identify what you think is a root cause, you form hypotheses and design experiments to test them. And you determine how to measure the results and what the results should look like if your hypothesis is correct. That's all plan. Then you test, measure, and reflect. That's do, check, and act. Do, check, and act can be done quickly if it's a 10-minute problem. If it's a more complicated problem, it often takes several PDCA cycles, breaking big problems into pieces. The solutions to one problem often illuminate the path to solving the next, often in unexpected ways. The more quickly you can complete each cycle, the faster you can move to the next. This is called rapid iteration. As you're about to see, the A3 method helps us do just that, break a problem into pieces and prioritize and solve them properly, keeping track of how they impact the larger problem we're trying to solve. Practicing rapid iterative problem solving helps individuals and teams develop confidence, becoming more and more skilled in finding and solving problems in a way that they can sustain them, build on them, resisting natural entropy and backsliding into habitual ways of thinking and acting. Let's take a moment and reflect about the plan step and the importance of data and evidence. Here's an example of an A3 template from the book Managing to Learn by John Shook, a book that tells the parallel stories of a problem-solving journey through the eyes of a coach and the learner as they encounter and overcome common challenges and thinking errors. As you can see, the A3 is shown as a form with 7 boxes representing the learning steps. I've noted P, D, C, and A on each of these boxes. Notice do, check, and act are the last 2. Remember how Einstein said he would spend the first 55 minutes of his allotted hour on planning in order to understand the problem and ask the right questions. Here's a learning tip to an 8-minute video by John where he helps you understand the foundations of this thinking process. Well worth watching and reflecting on. For now, we'll focus on step 4 of the A3. Problem analysis, also known as root cause analysis. Note what the author says, and this is a critical idea we'll return to later in the exercises. Use the simplest problem analysis tool that will suffice to show cause and effect down to the root cause. Einstein once said, "Make everything as simple as possible, but not simpler." In order to use the simplest tool to do the job, we not only need to understand a few key methods, we also must assess each problem to determine its characteristics, what approach is best to start with, how much data is needed, and the degree of quality, accuracy, tolerance, and precision that are appropriate. So let's start by talking about data and evidence, which are the raw materials of analysis. What is data? To answer this question, here's the classic knowledge pyramid. At the base of this pyramid is data. These days we're overrun by big, messy, raw data. It's like a never-ending waterfall, Many of us have difficulty shutting it off, quieting our minds to process it. When we organize this data in some way, we create a useful context to make sense and solve a problem. But we must be careful not to introduce distortions into the way we gather or structure the data we use, or we're bound to repeat the same problem we've been trying to solve. Common distortions include biases, preconceived notions about the problem or its solution, asking the wrong questions, using invalid or irrelevant data sources, misinterpreting statistics, seeking to place blame rather than doing the work necessary to actually solve the problem, and not including a variety of perspectives on the meaning of the data. As we work with the information and apply it to the situation, we see patterns, cause and effect relationships that guide us to outcomes we value. In other words, we grasp the underlying meaning. And over time, we develop insights that help us not only solve problems, but look ahead to anticipate them and to be proactive about how the decisions we make today may influence what may happen tomorrow. Wisdom is not guaranteed. We only achieve wisdom if we learn how to gracefully navigate the pyramid with each new input and problem. And as we all know, having more data is not necessarily a good thing. Like being trapped in a fast-moving river is not necessarily helpful to a thirsty person. Of course, these days, big data, advanced analytics, and artificial intelligence are here to rescue us. And if you've been paying attention lately and developed some degree of wisdom, you would instantly be skeptical of that last statement. VUCA, volatility, uncertainty, complexity, and ambiguity, have become the new normal in our daily lives. Big data, advanced analytics, and artificial intelligence have the potential to help see things at a scale and in ways humans can't, leading us to powerful insights and potentially effective solutions. But we must be careful. In just the past 5 or 10 years, AI has gone from the realm of science fiction, of always being just another decade away, to happening now, very quickly and in unexpected ways. And I expect it will become more accessible and affordable, even to individuals in smaller organizations over the next few years. Then there's the future potential of quantum computing, which I only understand at a basic level, but it's already being done in specific situations, and it appears to be quickly gaining speed. According to the experts, and excuse the pun, it will create a quantum leap in computing power, leading to unimaginable advances in the ability to solve extremely complex problems facing humanity, if we ask it to, that is. All of these developments with data and AI seem a bit too unsettling to many of us. They seem to be moving too fast, outrunning our ability to explore them safely. Many of the scenarios science fiction has explored for decades suddenly seem possible and a bit frightening. Most of these emerging AI technologies are currently driven by investments from corporations and governments who usually have self-serving agendas, and these systems can, intentionally or otherwise, cause widespread harm. We've already seen that happen many times, and we're all living with the uncertainty of this in one way or another. Some experts are now warning of a potential AI arms race. How do we turn this around? Deep inside every algorithm is a focus on the problem to be solved and the solution to be optimized. We must rely on someone to apply these technologies to ask the right questions, solve the right problems, and in the right way. This requires a focus on the right values. We can't always trust corporations or governments to make these value decisions properly for the good of all. In my opinion, it's up to NGOs and nonprofits to use them in ways that serve humanity, the planet, and our future generations. A good example, but certainly not the only one, is Bill and Melinda Gates Foundation, whose global access data analysis and learning platform gathers data from countless experiments, making them widely accessible. This amplifies and accelerates innovation across the global community. In his recent book on climate change, How to Avoid a Climate Disaster, Bill Gates breaks the challenge of climate change down into a number of key root causes and explores approaches to solving each. He is very clear that we don't currently know how to solve these problems. We must learn and innovate our way to solutions. And while new technology will be essential in solving many of these problems, he emphasizes the symbiotic relationship between humans and technology that is required to make this happen. So here's the challenge. In some cases, AI can do some of our thinking for us, seeing things in ways we can't. But we shouldn't let it solve our problems, just support our human decision-making, our judgment, and our values. We can't let AI run on autopilot. We must develop our problem-solving skills. And that begins by asking the right questions, guided by the right human values. Once we ask the right questions, we need the right data. And good data is difficult to define. It's not black and white, despite what statisticians may tell you. It depends on what you're measuring. Let me explain. Here's one possible answer to the question, what is data quality? This was my starting point when I facilitated a roundtable discussion at the San Francisco chapter of the Data Management Institute in 2010. It was a spirited discussion 13 years ago, and back then we knew very little of what was coming with social media, big data, and artificial intelligence. But many in that room, the heart of Silicon Valley and the internet boom, were already thinking about how it might emerge. In preparation for my second book, which I published 2 years after this session, I developed this list, suggesting potential sources of data to consider. The volume, velocity, and variety of data since then have exploded, and so have the distortions created through social media, deliberate disinformation campaigns, and many other causes. I expect information overload and deteriorating information reliability will continue to increase, so we must be prepared to deal with it. So back to the question, what is a practical definition of data quality that we can use? Data must meet the specific needs of each moment. However, statisticians often insist on a high degree of rigor, precision, and accuracy, and the need for very large sample sizes to produce valid results. But let's face it, we don't always have the time and resources and access to sufficient data. Some problems require more rigor and accuracy than others, especially when we're on the front lines, working in very difficult situations, constantly facing 10-minute problems, as well as larger ones. So we need to make well-informed decisions in a practical way, learning how to gather the right data and evidence, applying the right problem-solving methods and tools in an appropriate way to each situation without wasting time and effort. In lean terms, we should avoid the waste of over-processing by putting too much effort where there's little value in return. To arrive at a working definition of data quality that can be applied to any situation, Joseph Juran, one of the pioneers of the total quality revolution, defined quality in 2 simple ways: fitness for use and fitness for purpose. Fitness for use means the degree that something works as designed without errors. The data must be reliable and reflect reality. I like to remember this as the 3 C's. Is it clear, correct, and complete? Fitness for purpose means that it meets the specific customer need at the moment, that it is capable of solving the particular problem, not too little, not too much, and of the right kind. We sometimes call this the Goldilocks characteristic. So in each situation, we must understand the necessary degree of tolerance, precision, and accuracy of the data. For example, sometimes tolerance is measured by meters, like global positioning systems. Sometimes it's in millimeters, like when you're building a bridge. But if you're making a medical device, the tolerance can be quite a bit smaller. And if you're building a component to go into a space vehicle, it can be even smaller yet. Six Sigma is a total quality management discipline that emerged in the engineering world and has been used by companies in many industries that rely on a high degree of precision, like semiconductors, healthcare, pharmaceuticals, transportation, insurance, and banking. There has been considerable disagreement among Lean and Six Sigma practitioners over the years, and I'd like to clear that up. Six Sigma has two connotations. First, Six Sigma is a name given for a category of data-driven analytical problem-solving tools and methods. The 6 in Six Sigma refers to the number of decimals used for precision. Sometimes 6 decimal places is necessary, like delivering the right baby to the right mother or landing each airplane safely, right the first time every time. Other times the required precision is less, often much less. And sometimes this requires skill to determine how much less. For example, when delivering food and water to a region suddenly devastated by an earthquake, what is the tolerance for food safety when thousands are dying of hunger each day? What is the trade-off between first response speed and safety in saving the most lives? This is a complicated question involving judgment and trade-offs between first response speed, safety, and effectiveness, and the right approach may be quite different than the rigor required in an ordinary commercial kitchen. The second connotation of Six Sigma is troublesome, going back to the original way it was deployed in organizations. This approach is often associated with Jack Welch, an infamous and authoritarian leader of General Electric, where Six Sigma was to be applied by teams of experts, whether employees or consultants, highly skilled statistical gurus, often called quants, or quantitative analysts, who were sent to various parts of an organization in order to fix them, to do it to them rather than to help them learn to do it for themselves. Clearly, as you've come to understand lean thinking and the importance of problem solving, this can be a harmful approach. Though solving a particular problem at any moment in time is obviously important, the key to long-term success is to develop problem-solving capability of each team and individual within the organization, so they can own their processes, their outcomes, and be prepared to address whatever changes and challenges confront them in the future. So Six Sigma as a category of data-driven analytical tools is quite necessary when used properly with the right type of problem. It is, however, wasteful when applying to a problem that does not require such a high degree of precision. And most importantly, relying on experts, consultants, or other authorities to solve problems for you is only appropriate when conducting an immediate intervention when significant harm is about to occur. But then the situation should be handed back to the team for ongoing continuous improvement. We'll discuss that specific scenario later during part 2 when we will explore different types of problems. So how do we determine the degree of data precision that is good enough for the situation? Here's a quote from investor Warren Buffett, known for his practical sense of what's important. "It is better to be approximately right than precisely wrong." The takeaway from this idea is that the emotional desire or learned insistence for precision often gets in people's way when trying to make important decisions in conditions of complexity or uncertainty. This is commonly called analysis paralysis. Rather than insisting on applying rigorous statistical precision, reducing uncertainty with thoughtful estimation is often enough to guide decision-making in the proper direction so you can start asking the right questions and begin understanding causality through experimentation. My favorite source on this subject is How to Measure Anything. Hubbard is a brilliant data analyst who makes many convincing and practical arguments on data quality and value that you may find helpful in determining how much effort you invest related to the complexity of the situation and the return on investment of additional effort. Here's a learning tip to a free online summary of the key points in this book to help you determine what you need to learn about a situation to make a reasonably confident decision. This is worth reading. It should only take you 10 to 15 minutes. I'm now going to wrap up part 1 of this training by returning to the data pyramid with a few remarks on why it's important to understand organizational context in order to solve many problems that you'll encounter. While some people will argue that facts are facts and they're black and white, that is rarely the case. Even a physical measurable fact like cold versus hot is subject to interpretation. What feels hot to a polar bear feels comfortable to a camel. It depends on the individual's perspective, on their context. In any organization, there are usually a variety of perspectives. The perspective of a frontline worker doing the daily work, engaging with the customers, is likely quite different from a senior leader. They may both be looking at the same situation and at the same data, but one is looking through a telescope while the other is looking through a microscope. And often, within the larger organization, different levels and roles within the organization are not using the sets of data. Those on the front lines, involved in the daily work and the flow of processes, are using very detailed, granular transactional data, while those in leadership roles are often looking at very summarized data, often abstracted into spreadsheets, PowerPoints, and dashboards. To make it even more difficult, a process is likely to pass through a series of handoffs across a number of systems and databases along the way. Each of these may have their own design and data quality issues, and they often don't agree with each other. This, I'm afraid, is quite normal in most organizations because situations usually change faster than information systems can keep up with them. So we need to learn how to deal with it. Then, when it comes time to assess a situation, to measure it, to draw conclusions about it, to find meaning in it, in order to take some sort of action, individual motivation, goals, and biases can greatly influence each perspective. What feels like a big problem to a frontline worker may be perceived by a senior leader as just an inevitable issue, a fact of life that they should learn to live with. But it is a problem if it prevents the frontline worker from delivering quality outcomes to those they serve. I could go on and on with various examples and various reasons why organizational dysfunctions exist and why they naturally resist continuous improvement. It happens naturally as a consequence of bringing people together in a variety of organizational types and structures. Fortunately, there are principles, practices, and tools that can help. And that's what we're going to cover at a high level in part 2, to set the stage for identifying different types of problems and how to approach them in part 3, followed by problem-solving hands-on exercises in part 4. And then we'll finish with optional additional topics in part 5. Congratulations, you finished part 1. I want to leave you with some words of encouragement. Learning problem solving, like anything else worth doing, takes time, patience, and most of all, practice. We learn by doing, by building cognitive connections and muscle memory. So take your time, do the work, and stick with it. You've got this. We'll see you in part 2.